Next, coming to the stage, we have Mr. Matthew Lista. I think I pronounced that properly. It's Matthew Lista. Matthew is the managing director of JP Morgan Chase. He's been involved with the project almost from the beginning. And he's going to moderate our next panel with Microsoft and Broadcom, where they're going to have some really cool announcements about FBOSS. Welcome.
Morning. So I'm, yes, and Corey did get my name right. I drilled him quite extensively on the pronunciation. So I'm Matthew, and then with me I have Najam and Ram. Najam is with Facebook, responsible for networks, and Ram at Broadcom, responsible for switching. And so we're going to talk about some of the announcements you heard last couple of days around OpenNSL, FBOSS, and the open ecosystem that you're starting to see emerge. So, with that, let's dive right into it. So Najam, can you just, from a high level, tell the audience about OpenNSL and FBOSS and a bit about how it came about?
Sure. You tell them about FBOSS. I'll tell them about OpenNSL.
Okay. Well, let me give you some background, which I think might be more useful. We started this network project May in 2014, and one of the first things that we felt that we needed to do was disaggregation, where take the network appliance that was a very black box, vertically integrated environment and break it down into its components, so each component can be actually scaled and you have multiple options for each sort of component within the stack. If you look at the first projects that we did, build a top-of-rack switch, essentially hardware, but no software. At some point, we needed to sort of solve the software problem as well. And that's where FBOSS comes in, is one of the software options that you have on a bare metal merchant silicon-based platform. OpenNSL was one of the things that was needed, and I'll let Ram talk more detail about it. But what we're really trying to do is build an ecosystem where you have multiple hardware options and multiple software options available. FBOSS is one of them.
Yeah, and then maybe a little bit of detail about the FBOSS agent itself and how that sits in the ecosystem, and then we'll certainly go into OpenNSL in detail.
Sure. So FBOSS agent is designed to sort of give you a development environment, if you will. It provides you basic functionality that you might need in a switch like ARP, DHCP, LLDP, NDP, things of that nature. And then you have discovery of links or discovery of devices that it does for you. And you can build on top of that the protocols that you need. So BGP, OSPF, or things of that nature in terms of what your requirements are. So it really just gives you a development environment that you can actually grow with.
Yeah, so a relatively simple, starter kit as such.
Yep.
So Ram, OpenNSL, okay, the details of it, and a bit about how Broadcom got to that point of delivering this out as an open project.
Yeah, a few quarters ago, Najam surprised us saying, hey, we're building an operating system. I said, fine, you're building an operating system. What's the big deal? He said, well, I'm going to open source it. We're like, OK, so what does that mean to us, right? And he called us and said, look, you have an SDK, but it's hard for me to distribute my operating system openly if the SDK interfaces are not open. That kind of got the thinking going on our side, saying, OK, look, there's going to be a lot of innovation happening in the marketplace, and we need to think differently than how we've been thinking about it in the past. And we came up with this concept of OpenNSL, which is Open Network Switch Library. And effectively, it is a binary of our APIs that sits on top of our SDK that allows for these openly developed stacks to be both developed as well as distributed, right? So that's kind of the the genesis for how this started. And we see a lot of excitement. We've seen other use cases kind of evolve from what we've started, and we are committed to it. No.
And then you mentioned the SDK itself. Could you contrast, OpenNSL versus SDK and use cases where one would use one versus the other?
Yeah, I mean, our SDK has been in existence for many years now, supporting a host of our switch silicon. What we've done with OpenNSL is focused on a set of APIs that are useful. We primarily focused on the data center to start with. And the big differentiation between the SDK and the Open NSL is that the APIs are open and they are exposed, and they're easily available for distribution. Right? Our initial delivery of this is layer 2 and layer 3 and instrumentation and monitoring capabilities. I expect over the period of the next few quarters, we'll open up more and more of the capabilities through Open NSL.
Great. And you said this got instigated by Najam telling you that he needed this out, but I assume there's a broader motivation for Broadcom to be doing this, and this is a pretty big departure from historical siliconing involvement, and opening up to the community is very different than traditionally being focused purely on the vendor community.
Absolutely. We look at all these open initiatives, and the net of all these open initiatives is it accelerates the pace of innovation in networking. And our view is there's so much capability that we've already built into our silicon. In many cases, it doesn't get exposed because it is not fully exploited by the stacks which are being built out there. To the extent that we can make that freely available, it'll move the whole industry forward. And this is not new to us, by the way. If you look at the other initiative that we delivered on a couple of quarters ago, which is OpenFlow data plane abstraction. Essentially what we did was we provided a binary that allowed for all this OpenFlow-based applications to be easily mapped onto our silicon. So, we see this as a continuing trend, both in the industry as well as our commitment from Broadcom to enable this broad ecosystem. Great.
We've heard during the conference about a couple of other acronyms as well, one of them being SAI. And you got SAI, you got the FBOSS agent, you have OpenNSL. Najam, I think it'd be helpful to just talk through the different pieces and how they all fit together.
Sure. First, it was just not me. It was the whole OCP group asking for, hey, how do we make this ecosystem work? I think that's the key point is the traditional users of the SDK were OEMs that were building software platforms or platforms for other companies to use. That profile has changed, and there are a lot of network operators now actually talking to the chipsets directly. So there was a need for some level of interface that is open, and then we can share code through various ways to do that. So OpenNSL is really important from that perspective. Now, going back to disaggregation, the idea was to provide different levels of functionality and support depending on what your needs are. So if you think about it, you could still use SDK, get a license from Broadcom, and build on top of the SDK. Or you can start building on top of the OpenNSL interface. The SAI project that Microsoft's leading along with Broadcom and others is actually building a hardware adoption layer, which gives you more functionality on top of the OpenNSL. So you can think of that as a SDK with an OpenNSL interface, and then you have SAI, which gives you more functionality on top of the OpenNSL interface or the SDK, whichever one you want to choose. So as a developer, you have the choice to go directly to the SDK or OpenNSL or SAI, depending on what you need. And if you actually throw a FBOSS agent that we're open sourcing at this OCP event, you have another set of options where FBOSS agent actually provides you functions like ARP that are atomic functions that you can call through the FBOSS agent. So it really depends on how much effort you want to put in building things you want to build.
Yeah, no, that makes sense. And if I think about the FBOSS agent itself, and it's a relatively, and you've described it as a starter kit in some ways, it has a set of great functions, but it's also need and requires a relatively sophisticated user as such. So what are the other options? If you think about the wedge switch that you've been that we've had out in the community and now starting to be manufactured, and you've seen on the floor here.
Yeah.
Some of the other options, if you wanted to run something maybe a bit more what I call sewn together as such.
Yep.
And no offense intended. I mean,
definitely, the ecosystem is really, really important, and having options that people are comfortable with. So if you look at just the landscape today, you can get a wedge platform or any other OCP hardware platform with the Cumulus offering, which is a commercial offering, fully supported. But it still gives you an environment where you can write your own code in Linux user space if you wanted to, and extend it and add things like monitoring other capabilities that you may want. So, but that's a fully commercial offering supported. Big Switch has developed the Linux stack, and that's essentially a development environment based on Linux. It's open source, it'll be on GitHub, and you can download that and develop on top of that. They provide sample codes for different protocol implementations. So that's a little bit roll your own. And then you can go to the third stage where you're getting either SAI or FBOSS agent along with OpenBMC, and then you can put Quagga or whatever other protocols of choice you have, and that's sort of rolling your own to the entire stack. But you still have a lot of the fundamentals done, like you don't have to worry about temperature and how ports fail, and all of that work is already done in FBOSS agent or in SAI in some cases.
Yeah, I mean, this is certainly one of the beauties of disaggregation and moving to a model where you have a platform, because you're seeing different choices out there. And certainly as a customer, being able to choose different deployment models is really powerful. Yep. And so I think the fact that we got them there in such a short time. So when I started with OCP in 2011, we didn't talk about networks at all. And this really started in May of 2013. And so we made enormous progress in a year and a half in terms of getting to this model where we really have real and substantial different choices that are deployable and usable and are used in production environments. And on that note, Ram, how do you think this will change the ecosystem over the next, let's say, 3 years? So if you think about what you've done so far with OpenNSL and the broadening out, the SAI project, this community, if you forecast 3 years out, and clearly it's a difficult thing to do, but think about how this will impact the ecosystem.
The biggest way this is going to impact the ecosystem is, one, make it easier for people to distribute and share the innovations that they are doing, right? Now, longer term, as we all kind of look at what is happening with OCP and a lot of this activity here, the big chasm we have to cross is adoption. And we collectively have to think about what's the next step to drive this adoption. When we look at all these open activities and the networking, eventually people come back and say, how do I support and service what I can get, right? So for me, the big thing is, while there's a lot of innovation, how do we cross the next chasm, and how do we come together as a team to drive the last mile of support and service and the level of comfort that people expect? And a lot of the initiatives that you've seen from Dell, HP, and the others who've trying to pull that supply chain together is one step in that direction.
And when you go out and talk to customers, what is your the general reaction to the direction you take in? I'm talking about both end customers as well as your traditional switch customers.
There is general excitement, but there is also a pragmatism behind this general excitement. So people see the pace of innovation happening. Now they're kind of waiting for all the ecosystem to really solidify around it so they can start to take advantage of it.
Yeah. No, that makes. And Najam, from your perspective, being involved in the networking community with OCP and being one of the key instigators to begin with here, what do you view as success criteria? Is it, from your perspective, is it adoption? Is it further innovation? Is it the ecosystem?
Adoption. Yeah. Pretty much everything. But I think if we're sitting here next year and we are actually walking through how people took this technology and actually run networks with it, that would be the success story I would love to hear. That would just be really awesome to see at OCP, people doing case studies on this is what we did, and this is how we deployed it, and this is how we run and manage it. That would be success, because I think that will build everything else that we need. But in the end, it's an evolution. We're used to the world where you used to buy packaged solutions from a vendor, and then every time you needed to change, you had to go back to the vendor and have that package changed in some ways. And it was a very long, slow process. Now, if you look at the pace of innovation or pace of just software development, network just doesn't keep pace with it. That model just doesn't keep pace. So we need to be able to manage networks and evolve them at the same pace as software development happens. So for me, I think the big change would be how network organizations actually change. Over time, go from a very configuration-centric model to more of a software development model. And that's a mindset change in network engineering organizations, there's a skill set change. We've been driving that skill set change. One thing that we have experienced ourselves at Facebook is that the pool of engineers that we used to be able to leverage to run network has grown significantly as we've moved into more in the software-driven world. Because there's a lot of software engineers that know how to work on distributed systems and they're excited about it, but in the past they couldn't actually work on it. Now there's a lot more opportunity for them to actually come in and have an impact. So over time, this is an evolution where start with what you can do and then slowly grow. And hopefully the OCP network track is building technologies and you can plug in your environment based on what your capabilities are. Fully supported to fully roll your own, and you should have all models available in that sense.
Yeah, to lead on to that, and a question really for both of you. If I think about where I'm the most excited about this over time, so we're building a foundational platform, and as you spoke, there are different choices of how you run those foundational platforms. But the long-term benefit here is really the applications that you can write on top of the network applications. And I think we haven't even thought through all of those yet, what that will come. But I think we enable an ecosystem that allows enormous amount of innovation to come down the road. And so if you think, and either of you, from your perspective, what are some of those things that you think people will do that they just haven't been able to do historically because they haven't had the ability to directly impact the way the networks work from a product perspective?
I can talk about that forever. I could fill the whole time for that, because I've always been interested in running large-scale networks. But you could start with very simple things where every network organization has to build this NOC, a bench of people that are sitting in front of monitors watching how things are working, if there are things breaking, and reacting to it. That's a colossal waste of time. That's a colossal waste of human capital and human resources. If we can get software to do that, it'll be a lot better to do. So one of our goals, which we're really working very hard towards, is how do we get to a point where a single engineer is all that's required to watch a network at any given time. And I'm really happy to say we're almost there, and we're there in a lot of cases. That's the advantage. So the thought that we want robots to run the network, and we want people to build the robots. That's where the people capital should go. To me, that's the fundamental change. If you do that, then you will grow in leaps and bounds you won't even realize the kind of innovations you can actually get.
Yeah, and Ram, do you have a perspective on that?
Yeah, I mean, if you think about networks, right, there's the data center view of the networks, but then if you think about the network much more broadly, the service provider network, the mobile backhaul networks, there's a lot to be said about context awareness that a network provides that otherwise is very hard to get. That's one. Clearly, the other aspect of this is all about automation, to your point, which is it's very hard to build and scale these networks of this size. Once you even go beyond the data center end to end, all the way, into your home, into your mobile backhaul, and all the other aspects. So this notion of being context aware, the notion that there is so much data richness in the traffic that traverses the network, and being able to take all of this and have more visibility and analytics on it, and at the same time being able to automate at scale, all these are fundamental things that very large operators are looking for as ways to potentially even monetize the value that is traversing this network.
Yep. And in terms of the upper layer functions today that are typically offered through appliances or often in the industry, do you envision that those will shift over time into a pure software model that would run on top of these standard platforms?
I think in some cases, yes, depends on what your application is. If you look at most environments, a lot of load balancing is already done in software running on server platforms that we use for other applications. So it depends on application to application. But the key point is that you have the ability to analyze what you have going on in the network and then be able to do something about it. Having that control to do something about it is fundamental.
So we're close to wrapping up, but I'd like to give you each the opportunity to any closing comments and any thoughts you have about the next, let's say 3 to 5 years in this environment. So I'll start with Ram.
Actually, I'd like to turn the question back to you. You are a big end user of a lot of compute out there. What's your perspective?
Yeah, well, I wasn't expecting that, but yeah, I'm happy to answer that. So, I think from my perspective, we clearly deploy a huge amount of compute and networks at large scale, and for us, the biggest benefit to this openness is the fact that we can also build applications on top of this, just like Facebook are doing for their environment. Now, clearly, we have different use cases and different environmentals and different business drivers, but the desires are the same, which is if we can influence, get metrics and telemetry out of the networks, influence and control that in a lot more detail, it will allow us to do things that we cannot do today. So, for example, how we build our trading environments, I can envision we could use a lot more instrumentation there to do a better job. I agree with Najam, have the people build the robots and how the robots operate in the environment, incredibly helpful. And also just being able to build more security in the environment by being able to introspect data and react to that very quickly. So I'm very excited about this whole movement because it allows us far more leverage than we've had historically. Najam, anything?
Well, I think I've covered some of the things that I'm focused on. It's essentially giving network engineers the ability to actually modify the network over time, and we'll develop use cases as we learn, because that's the biggest thing that happens when we find something. Can we do something about it? And that's the key we're trying to drive through this OCP effort.
Great. Well, thanks everybody. Thanks for your time, and Ram and Najam, thanks a lot for the panel.
Thank you.
Thank you.